Mm. Hey everybody, this is Larry. This is day 20 of the Leetcode November Daily Challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about today's farm. Today I'm in front of this flower thing in Buenos Aires. Apparently it's famous. And there, ooh, almost dropped my camera, that great. And there's the university, or Buenos Aires University, or Universidad de Buenos Aires. So am I supposed to walk on grass, but I don't know. But yeah, hope y'all have a good farm. I'm just walking around the neighborhood, and you know it's hard to miss this flower thing that's probably apparently famous or something. But yeah, gonna walk around some more. So let's go. Hey everybody, this is Larry. This is day 20th of the Leetcode Daily Challenge. Hit the like button, subscribe, and join my Discord. Let me know what you think about today's farm. Oh man, we have a hard one today. Hopefully not too hard, because I really want. I've been saying that every day, but I've been kind of wanting to go to bed earlier. But I have a lot of errands and tasks and so forth. And check this out. I'm rich, everybody. Wait, hang on. I did that wrong. Alright, well, whatever. How the numbers are only on one side? This is very confusing. Why is this not symmetric? This is actually confusing. Okay. Anyway, I hope you like the intro. I'm still here in Buenos Aires and hopefully starting to say it more correctly in Espanol. Pero mi español es muy mal. I don't know if that's quite right anyway. Un poco. My point is, alright, whatever. What I was gonna say is that, hey, look, I went to the, oh, Jesus. I went to the ATM to pick up some cash, and apparently the biggest bill they have is like 2,000 pesos, which is about like $1.20 or something. I don't know, something like that, right? So I took out like $80 USD, and basically it's just a stack of cash that I could like slap people with. I mean, don't actually slap people with your money, I guess. I don't know, but that's basically what my situation is, and that is very confusing. But anyway, all right, let's take a look at today's farm. I am just being confused right now. Anyway, my apologies for the weird intro. But all right, let's go. At 757, set intersection size at least 2. You're given 2D integer array intervals. Integer survive. Then. Wait, I didn't read it. Maybe I should actually read it for instead of saying All right. You have intervals, start and end, okay? A containing says the array nums where each interval from intervals has at least 2 integer in nums. For example, intervals 1, 3, 3, 7, 8, 9, then this thing and that thing are containing sets. Why is it containing sets? Because 2 and 3 well, okay. Okay, 1 and 3 has 2 numbers, 2 and 3. 3 and 7 has 3 and 4. 8 and 9 has, well, just 8 and 9, right? Okay. Okay. Let's sorry, I'm a little bit fuzzled today. There's a lot of, I don't know. I didn't even do that much. What is going on with me? But yeah, the worst case, of course, is just going to be each interval has 2 unique numbers, right? So you have like 2 times n is my point, right? So that's going to be your worst case. And then the question is, how do you optimize? Not gonna lie, whenever you find things about overlaps and stuff, and it's not part of the literature that I already know, I always look at the constraints first to make sure that it's not something crazy. 3,000 suggests maybe n squared or n log n. So okay, so that's a start. Start and end could be anything. So we cannot, abuse based on that. And yeah, because if n was like 10, then you know that maybe it is an NP, and you have to like do some NPE things. But 3,000 is okay. That's interesting. I mean, because it's not greedy, or I mean, it could still have greedy components, but maybe it's just something interesting, right? Okay, so yeah, this is part of the example. It can be shown. How can you show it? Show it to me. All right, come on. All right. So basic. I mean, the key thing to note. Trying to think. I mean, the big number doesn't actually mean anything. I think that's one thing that I maybe neglect a little bit, because you can always what's it called, coordinate compression, right? What I mean by that is, for example, in case y'all don't know what that is that you have like coordinates like 1, 100, 5, 7, but all that matters is that things are relatively, right? So maybe you sort them, it's 100. But again, all that matters is things are relatively. Maybe there's a little bit of like +1, -1, but it doesn't matter, right? Because then you can just because only the relative order matters. Then now you convert them to 1, 2, 3, 4, and then kind of do things that way. Again, for this problem, maybe it's a little bit more nuanced with like, you know, you have to compress things so that each range can be a little bit wider. And keep in mind that each interval has at least 2 numbers. And I think actually coordinate compression would make perfect sense, just because in this case, and for me, what I'm thinking is just case analysis, right? And this is where I wish I'm at home, where I can draw it. But you just kind of and I don't know that I'm advocating for coordinate compression. It may be cool, maybe it's not necessary. But I'm just saying that. But you know, one of the things that you can do during you know, these practice, these daily problems, is just to kind of think about it in an interesting way. But for example, without loss of generality, you can think of just having 2 intervals, right? And we have 2 intervals, there are really only 4 cases, right? So you have this, right? And then you have one within each other, and then the other one within each other, which is the same, right? So kind of 3, kind of 4, depending on how you want to count it. And what I'm saying is that in this case, and let's just assume, I mean, I guess there are more cases if you select the endpoints to be the same as one of them or something, if they overlap. But for this problem, if they overlap, they're actually kind of trivial, right? Because you just choose an overlap. But my point is that here, without loss of generality, you can just compress them into 4 numbers, right? Because it doesn't matter, because you only need to create 2 numbers anyway. So you just probably choose something like this and this, right? And that's the idea of coordinate compression. I don't think you need it though, actually, honestly. But I'm just saying that, you know, these are things that you can think about, because then if you were to go down that route, then here you have at most 6,000 numbers, and then here is 6,000 things, and you can maybe think about doing something like that, right? With 6,000 square, it's a little bit slow still, but you're starting to think, okay, maybe I can do something n square over 36 or something. I don't know, whatever, right? Something crazy. Give me a second. I gotta plug in my power. Got the power, dude. Okay. Okay. And then what's next? What's next is, I mean, I think the idea that I would go to is some sort of sliding window, or not sliding window. Sorry, sweep line, which is similar but not quite the same. Because then now we have like all these intervals, right? I'm drawing with my touchpad, so you know, doing the best I can, kind of thing. But yeah, so let's say, you know, you always sort them a little bit. It looks something like this. Then now, in a greedy way, if you have to pick a number in here, right? Let's say we pick this one. Well, you're never gonna pick the beginning. Well, not in this case, because it goes here, right? So then now, when you see another number, it almost is like the most overlapping thing, right? So then now you go here, because this satisfies the most. And then here, you know that, oh, I still need one more, then maybe you put it here, right? And this happens even if you have like something like, I don't know, something like this, then here, you know that you have to satisfy 2. And here, maybe for this one, you actually need 2, so you go here, which only satisfies 1. So I think this kind of makes sense as an idea. Implementation-wise, I'm not quite sure. Yeah, I think the idea makes sense to me, right? But implementation-wise is a little bit, or I mean, I don't think it's impossible or anything like that. May not even be difficult. But for me, it's just like a little bit, for intervals, for each one, you have to count 2 numbers. Maybe that's a little bit odd to keep track of. I think what it does remind me of some sort of heap type things, but I'm not quite sure, right? And then I'm trying to think whether, like, if we do the path, let's say we do the coordinate compression and just, sweep the line, right? I don't think you're greedy in sense of like the most intersection, because that's not how that works. So I'm trying to think what would that mean, right? Yeah. I feel a little bit tricky. Did I put it? Okay, I did put, I was wondering why I drew this on mine. Okay. So I think definitely there is a sorting. I'm trying to think what is the best way to handle it in terms. So I usually do this with like events processing. I'm trying to think what is the best way to handle this with a sweep line. So we have a start. You have an end, right? What is the logic? I'm trying to think whether I can separate out the endpoints. I don't think we can, but I'm just trying to think. Man, why am I so bad at this? I've been bad for a while though, so I don't know. Because if it's just one, then it is the interval, the number of, what's it called, overlapping intervals or whatever it is, right? Okay, maybe I have to sort a little bit differently, right? I mean, maybe we sort by, instead of a sweep line, right? Because I think this reminds me of another type of greedy plan. You sweep line by the endpoints, right? Or the end time, because here, that is the, sorry, I got a ping. Because here, then now, if we sort by the endpoints, then this means that we're sorting by the last time we can do it, right? So what does this mean? So here, we sort by here, then you get here, right? So then now, what invariant do we get going from here to here, right? And it's really hard to draw on the touchpad. The invariant is that everything to the right, there are two cases, right? That either, and I didn't draw both of them somehow, either ignoring the ones in the middle, we know that the right endpoint is going to be afterwards, right? So then that means that the left endpoint, yeah, the left endpoint, if that's before or afterwards, right? If it's afterwards, then, well, you know, we don't consider it. If it's before, then we just, if it's before the left endpoint, have I done this before? Oh, I haven't done this before. I was like, I really don't remember this. Even though I usually don't remember it anyway, but I really feel like this is so fundamental that I would have remembered it if, maybe not, I don't know. Either way, I don't remember it because I don't know it or I haven't done it. Okay. This is the type of greedy problem that I am bad at though. So, okay, so that means that if this is on the left, then what does that mean? That means that, okay, so that means that here, right? Oops. I see. I think I have an idea, right? Because if you sort it this way, then now oh, I tried to change the color. I don't know why it didn't come out. What did I click on? Why does that happen? Anyway, so you drew here, right? So that's going to be your first point because that's the last point that you can go anyway. And by definition, at least for the first line, this is the first last point, the first last point. So that means that, yeah, right? That means that if all the intervals that intersect, either they intersect or they don't intersect, but there's no intersection in which you do something like this, right? Because by definition, you know, this is the first one, right? Okay, so if this is the first one, okay, so you have these two cases. Then now, of course, in a greedy kind of way, you would also choose the one next to it, right? Let's actually redraw this for a second. Let's just pretend they're in the same line because that's a different case. Okay, so then you draw the last line, right? Okay, and then now you draw the x minus 1 or whatever, right? And then now, in the next case, then now we just kind of, okay, in this number, we go, okay, we're done, right? In this number, well, we have to draw a 1. Will we draw one at the very end? I guess so, right? Because now this gives us the invariant, except for that in this case, you do not draw x minus 1 or whatever, right? Okay. And then now we can say everything. I'm trying to think whether it, so right now, because we are doing it by the last endpoint, this case is not possible, right? You cannot have a case like this as an interval, right? So every interval in the future, again, same as the first one, except for now we have one endpoint instead of two in the way that we drew it. Yeah. Trying to think. Okay, so now we have 3 points, right? Do I put it in a data structure somewhere? I guess so, right? I think that's it though, right? We could use a sorted list or something. Because we know that, so every, like going forward, let me change the color again. There are really only 2 cases. There's either this intersection and then not intersection. If it intersects, then either you intersect in 1 point or 2 points. And if it's not, then you know that, right? So then now, if we put in all these numbers one by one in this way, we can just do a binary search for every interval. So here we'll just, binary search for the beginning and the end, and then determine how many we need. And in fact, if we just do a binary search for intersection, we take care of all the cases, right? I think that's right, but I'm always like really bad at this because I don't know. I guess it is something that comes up enough times, but sorting by the endpoints always, because I'm so much used to doing sweep line with respect to intervals and stuff like that. but yeah, okay, I think that's all I have. Right, so we can start implementing a little bit. Oh, I made, the only change I made was I sort by this, because before I had this, I think. I forgot to take this off. Okay. And then now for X, Y, or start N, I don't know. I don't know why is my keyboard weird, or my fingers weird? I don't know. Okay, so then now we have, let's just say we have a sorted list. I don't know why I write it like this. Like it's another language, I mean. Okay, right? And then now we do a binary search, right? We search for the beginning. sl.bisect left. Start. I always get it wrong though. Is that right? Left index, right index, right? That it should be inclusive of start and end, right? So then now, if the intersection contains 0 numbers, I don't know. I was thinking about writing it's a little bit smarter, but I just want to get it right for now, right? So then now we add n, right? And we also add n-1, maybe in this one. I don't know. I don't think it matters, right? And then else if, I guess this could be, I didn't need to do it like that, right? N, right? Yeah, and then else, and then we're good else, right? So now we return length of SL, and I think hopefully this is okay. If not, that's good too, because key. If not, it's good, because then at least we figure out what's wrong. Looks okay for now. I'm not super confident, honestly. These greedy type sweep line thing is always tricky. Ooh, okay. I put 4, but answer is 5. Why is that? Why do I think 4 is enough? Did I miss a case? Huh. Oh, okay, I'm dumb. Yeah, I mean, but how did it do that? I mean, well, one thing is we can obviously just convert this to sorted set or something, but that also means that something else is weird. So I just want to make sure that, like what did we add? What happened to make it add 7, 7, right? So, okay. So the reason is, oh, I see, because it was 3, 5. Is my sorting right? Or like, I mean, I think the sorting by the endpoint is right, the end right endpoint, but the left one maybe it's not. I don't know. Okay, so 3, 7, 3. So 2, 3 on the 1, 3. 3, 7. It goes intersects with the 3, so it adds 7. Okay, 5, 7. 5, 7 actually intersects, so it doesn't need to add anything, right? Oh no, 5, 7. So 5, 7 to 7, but 7 already exists, so, because, yeah. So this is, I guess, an edge case that I just didn't consider. So set should not be necessary, but if n not in SL, right, else sl.n-1. I think that should be good, at least for this case. Yeah, a very silly mistake by me, but I think I'm like greedy problems are just hard. I think that's so. I don't know. I don't feel bad about. I mean, maybe I should feel a little bad, but it's not that big of a deal. Because for me, it's more that I wanted to. Well, it's not even that it's not a big deal. Honestly, it's just that I'm not as confident about. Like I'm less confident about the algorithm versus the edge case, right? Because if I'm confident about the algorithm, then I could work on the edge case. It's easy. It's easy to kind of think through. But it's just that I wasn't confident about the algorithm in general, which is why I didn't do it. But yeah, hopefully this makes sense. Kind of nutty. I mean, this is clearly n-log n due to the sorting, and then just a lot of binary search, right? And a lot of adding on the binary tree-ish thing. I know it's not implementing a binary tree, but that's how it goes. But yeah, that's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.